An important benefit of using contracts is that they end up separating your interface of your code from its implementation. Now, that's something that you enjoy all the time, that split between interface and implementation, on things like abstract data types that have been written by other people, lists, sets, maps, those kinds of things. And you enjoy that split because they have the contract. You know what you get from the contract, and you don't have to go read all their source code in order to understand how it works. So with this, what I'm going to try to explain is that you should be enjoying that split on your code too. And the technique that we're going to use is to vary the amount of formality that we put into the contract and still get the benefits of it. I'm going to click on the right window this time. All right. So all too often, we enjoy using other people's code that has an interface or implementation split, but we don't end up doing the same thing on our code. And that's a shame because it's a huge help. The real question is, what can callers depend upon? Is it what the method body does, what the method signature allows, or is it some contract? And those are sort of an increasing level of specificity. So we all enjoy that interface split with lists and array lists and linked list. Okay, we know what we get with each one of those. And it would be great if your code could enjoy that separation as well. Now, when we talk about specifications, that's what we're really talking about when we're talking about contracts, okay? And specifications sound scary. It sounds like a word out of the 1970s. It sounds like binders of printed materials on shelves, and it's the kind of thing that we don't do anymore. But really, that's not what we're talking about here. Those are what were called whole program specifications, and we rarely do that anymore. What we do instead are little specifications. So on an individual method, we put a specification there, or maybe on a module. The interfaces of abstract data types like lists and maps and sets and so forth, they all have specifications. By the way, they all came out of the 1970s as well. So those specifications are what give us the split between the interface and the implementation. It's why you almost never read the implementation of those things. So the specifications are what the caller actually depends on. They depend on the interface. And when we write a set of names of operations on our data structure, and we can see those names, what happens is callers will infer what the specification is. And the problem is, if we don't carefully state what the specification is, we don't state what the contract is, they're going to guess. They're going to infer the contract incorrectly. And so the big idea here is that you should state the contract specifically, and you want to do that with appropriate naming of your methods and also in the comments. The big idea is that you don't want to make anyone read your implementation. If you don't put specs on things, you are putting a burden on everyone else. Okay, and here's the thing that you may not recognize, depending if you're early career or not, because you have a tendency to write assignments for class and you forget about them and never see them again, is that you will see that code you wrote. You will see it again in another month. You'll see it again in 6 months. It'll come back to haunt you 3 years from now. You'll get an email that says, hey, remember that thing you wrote a while back? We're having some trouble with it, and we want you to rope you back in and destroy your week. So really, the point is that having that interface implementation split, you may be the primary beneficiary of that. You want to be in a situation where callers shouldn't need to read the implementation. And here are some example cases which might force them to do that. They might wonder, can I pass in this parameter as null? Well, maybe they're going to go read the implementation and find out. Well, can I have a map with a null as a key? Again, they might go read the implementation. And here's the worst. If a caller has called your method and they're wondering, well, what exceptions might it ever throw? Well, they might go read the implementation, but what's worse is they might need to recursively read all the methods that you are calling from your implementation, which I can promise you takes a long time, or it's sort of like whack-a-mole. Like you see a runtime exception in your code and then you start looking for that afterwards. So the message that you should take away from this is that if you don't put a contract on your code, no matter how lightweight you put it in there, the implementation de facto becomes the spec. And the problem is, once the implementation becomes the spec, your hands are tied. You probably can't change it. Or that is, if you want to change it, you now own all the changes to the client code that's calling into yours. And that's no fun. So what I'd encourage is a shift in perspective. It's not that you didn't know about the interface implementation separation. It's that perhaps you thought it applied to different code. It is something that you inherited rather than something that you built. So here's the old way of thinking about it, for example, that interfaces are a nuisance. And that, for example, you have one between the front end of your application and your back end. And that's sort of a necessary evil because they're running on two different machines. Or here's another one. I'm writing both modules. The two modules are talking to each other, so I don't really need an interface. Or I don't need to be very careful about thinking through the contracts or let alone writing them down. It's also a typing hassle and it's a maintenance hassle because, like, for example, if I have an interface file and an implementation file, if I change the signature on one, I have to update the signature on the other. So here's the way I would encourage you to think about it, is that interfaces are helping me, not just other people. I mean, the deferred gratification is good for other people, but it's really helping me. The interface is a specification saying what is it safe to depend on. And that's a kind of thinking that you're going to need to do sooner or later, right? Because in some ways, you realize that some of the lines of code you wrote were just arbitrary implementation choices. Like, I used an array list here, but I wasn't really thinking about it, okay? I happened to use one. But other things that you were doing, you really meant, no, I meant that as a decision that I'm willing to stand on that one and I'm not planning on changing that, okay? So by writing down the contract, all you're doing is really saying what that kind of thinking that you had to go through anyway. Once you've done that, it gives you the flexibility to change that implementation because you know what you've committed to and what you haven't committed to. It encourages thinking from a black box so that as you're not looking at the implementation, you're not tempted to read the implementation. And by the way, when I'm talking about a contract as an interface here, I'm not necessarily talking about programming language constructs like Java interfaces or C++ header files. I just mean the general form of contracts. Contracts and the signature plus the contract. So here's an example that there's something very similar to what I saw many years ago that caused us a huge amount of trouble. This is something that nominally had an interface, but it didn't do all the things that you would consider good form for contract-based programming. So in this situation, we had two different programs, had a client and a server, and the client sent the server a list of key value pairs. Now, both of these were written by the same developer. This developer was very proud of the fact that this was a flexible design, that they could change what's in these key value pairs, and they didn't have to do any extra typing of like changing the method signatures or any of that kind of stuff, okay? Just put different things into the key value pairs. And the problem was that you can also read that flexibility as the contract was always in flux. It was always changing, and the developer actually hadn't really made any firm commitments to it. So the signature on the server side had a very simple signature. It was something like receive and then a list of these key value pairs. Now, what was never stated in the contract and is not forced into the signature is that there were specific keys that were required to be present, and the server would barf if it didn't find those keys. And what's more, there was like dependent logic, like, well, if it found key number 1, it would go looking around for key number 2. And so this was an incredibly tight coupling between these things. And the only way you could find out about these rules, for example, that certain keys had to be present, and if certain other keys were present, they implied the existence of other ones, all that was only found in the implementation. Incredibly tight coupling, and this was 100%, the only way you could understand things was by reading the implementation. So just imagine a year later, you come back, and someone asks you, you need to write a compatible server, or you need to refactor that server. Suddenly you're going to be reverse engineering your implementation. And it would just been so much easier if you'd written the contract in the first place. So here's how you keep an interface implementation separation going. First thing is use contracts everywhere, from the littlest methods like isEmpty all the way up to server interfaces. But what you do is you vary the formality depending on where you are, what seems appropriate. So for example, little methods, you're really shooting for like one-liners on these things, 1, 2-liners. And part of that is you are seeking simplicity, and if you are successful in finding the simplicity, then you're able to write a simple contract, okay? And if not, you really start to ask yourself, can't I find it? Or maybe I just want to write a lousy contract on this, okay? Because it's small stuff. But then when things get bigger and you think about them as the APIs to your program, like there's going to be many people calling into the server API or so forth, those kinds of things need a lot more care and attention. You want to write out that contract explicitly in a comment, and you would definitely want to be using a language interface. So in this case, you would want to be using a Java interface or C++ header, and you would want to consider enforcing the contract at runtime. Now, this is just something to consider, but you should ask yourself, on the server, if it gets this message and the preconditions violated, do I want to go ahead and just stop now, or do I want to have bad, undefined behavior because the caller didn't do the right thing? So, in summary, what we're talking about here is something you probably already knew about, that it's probably a good idea to separate the interface from the implementation. And you take that for granted in a lot of code that you use out there, code that you consider to be high quality. And the reason you enjoy using that code is because the contracts on that code are very clear. They have separated the interface and the implementation, and you know what you can depend on. You can enjoy that same benefit in your own code. And I know it sounds strange to say this, but a lot of people just, the switch doesn't click in their heads. They don't realize, oh, I can also be the person that builds code that has that split to it, okay? And I can do that in a practical sense by varying the amount of formality that I do, from small methods with quick one-liner contracts to very large methods that have a lot more bureaucracy and ceremony to them.